Hello guys, in this session we're going to discuss about the welded connection and how we can design a welded connection based on the NZS3404. But before going further, the first thing you should know is what is the advantages and disadvantages of using welding compared with the bolting, well in fact the bolted connection. The advantages of it's no need punching or drilling, and it simplifies the complicated joints or connections. But the disadvantages of the welded connection is they need a, a greater level of skill for welding, and also it's more expensive than bolt, and also it need the weld inspection, and also it's expensive. You need to ask the companies or someone to check the connection, just the welding. So we can say the summary of the advantage and disadvantage of using the bolt connection compared with the the welded connection compared with the bolted connection. So when you're doing the welding, you should just know some kind of the symbols. We call it the weld symbols. You as a civil engineer should be familiar with all these symbols, because when you're going to provide a detailing plan, so you should have all the symbol on the detailing plans. Okay, the welding symbols, let me show you that. Okay, the welding symbols, yep. That's a symbol for welding, so you as a civil engineer should know that what type of the welding was at that part of the building. For example, if there's a connection here and you just attach a plate on top of a I section beam with the two lines of the welding, so you should show like this. If it's with this symbol, means that's the fillet welding. And if it's with something else, you can simply find out that what type of the welding you should do at this part of the structure. So there's a many types of the welded joints. So if we're going to summarize the types of welded joints, so we can say that the first one is the butt joint. Second is the T-joint. Lap joint. And finally, corner joint. So the butt joint, we're just connecting two plates. Yeah, you're just going to weld two plates, just call plate 1 and plate 2. And the T, you know that it should be in the T shape, and you will need to do the welding. It's both sides. and the lap. That's the lap joint. And what else? The corner joints, when you're going to connect two elements, which has the 90-degree angle. But in fact, now it should be, they always weld like this. So in the case that you're going to have a T section, you need to go for the T joint, and for the lap joints and the butt joint when you're going to connect two plates. And if you're going to have a 90-degree angle, we'll go for the corner joints. But if we're going to know how practically, they just do the welding in the real project, that the first one is definitely the butt joint, the second one is the T joint, lap joint, and finally the corner joint. So the types of the welded joints, we can say butt, T, lap, and corner. But let's see what type of the butt joints we have. Let's start with the first one. Number 1, butt joint. So the butt joint might be based on the cutting of two plates. For example, if we're going to connect these two plates, we always should try to have a better penetration between the two plates and fill this gap in the more effective way. So if you just leave it, because when you're going to fill this part with the welding, there should not be any void or any gap at the connection point, because it reduces the capacity of the weld. So in this regard, they just develop different types of the cutting. Cutting form, if with no cut, we call it a square, but we can say single V, single U, flanged W, double V, and a square, which is the one we have here. So mainly it's about the cutting of the two plates, how we're going to cut these two plates. To have a better penetration. For example, if we're going to connect one plate with another plate with the just say the single V, you should just say the symbol should be it means that we're going to have a kind of the fillet joint. That's a symbol for fillet. But if there was two with no cut on the edge of two plates, you should say it, we're going to just fill this part, and the symbol is two line, which is a square groove. we call it a square butt. So you can check the lecture note to get more idea about the different types of the welding, but it depends that how you're going to have the welding. For example, if we're going to fill this part, what type of the welding do we need? And if we're going to fill this part, what type of the welding do you need? That's all in the lecture note that you can, for example, you need a single or double U to just fill all this part. In this case, we need a kind of, for example, if it's like something like this, it depends on the form of cutting, the symbol will be different. In this case, it's something like this, that we're going to have a welding at this part. Okay, I don't want to spend more time on this topic, just to get the idea that what's the meaning of the butt joint and different types of the cutting, and what the symbols should be used when we're going to fill the gap between two plates. Okay, the second one is the T joint. The T joint, again, it depends on when this is always one plate, and the plan is that you're going to connect another plate to form a T section. But sometimes to have a stronger and better penetration, we suggest that you need to have a cut. And then in this case, you can have a better penetration and the connection will be in more proper way, because it's impossible to have the welding at this point, so it's better to have a cut to just increase the bonding between two plates. If you just call it plate 1 and plate 2, have a better bonding between two plates. For example, if we're going to just show the symbol for this welding, you should just when there's a cut, should be like this, but when there is no cut, it should be like this. With no cut, with a cut. And for example, if there is 2, then you're going to fill this part. You should say 2 sides. Means 2 sides of the plate you need to have the welding. Okay. And if you're going to see the different types of the T, I'm not sure whether I have or not. Yeah, the T joints. There are different types of the T joints that you can have. When you're going to connect two plates to form a T section, you should go through one of this pattern. The third one is the lap joint. When you're going to connect 2 plates this way, so we call it the lap joints, and it depends how we're going to do the welding and how we're going to connect the 2 plates. We have different types of the lap joints. Single lap, juggle lap, double, and so So it depends on the needs for the project, that you can have different detailing for the connection part. And finally, the corner connection. The corner connection, when you're going to connect two plates at the corner of one section. So then, in fact, it should be a full penetration. In this case, that's a fillet. That's a kind of the fillet joints. So you can have this symbol. And if you check for the corners, the only thing you should know is the symbol for the corners. The symbol of the connection. That's the different types of the connections. Mainly how we cut the connecting edge, and how we should show the symbol for this welding. You can refer to the lecture notes, but you will get the more idea how to select a symbol for any connection. Okay, the main topic is how we're going to design a welding, but the types of the welding. In fact, the types of the welds. The first one is butt weld. Second one is fillet weld, and the third one is compound weld. Okay, in terms of the strength, the butt welds is a kind of the acceptable welding, but always require a careful penetration of the blade, so you need to spend more money to just fill all the gaps. And in this regard, we have two types of butt weld: complete penetration and an incomplete penetration. And again, it's a butt weld. So the complete penetration most expensive weld to make. Develops full strength of the weakest member being connected. And good for static and earthquake loading. Earthquake loading, and it's a good welding for fatigue loading. So the complete penetration, if we're going to connect these two plates, it can be just place a plate here and then fill all the gaps. In fact, the full penetration through the connecting point, or you can just cut the edge of two plates. And also the second round is so you need to completely connect two parts of the connection with the welding. That's the full penetration. Just remember, for the full penetration you need to fully connect two parts of the, it means to fully connect the both sides of the connecting plate. When you're going to connect two plates, in fact the full penetration over the connecting area. That's why it's developed the fullest strength. It's good for static and earthquake loading, and it's best for the fatigue loading. And if in the final exam ask you, just explain the complete and incomplete penetration and show me through the and maybe give you that's one of those pictures and ask you which one is full and which one is incomplete. But the incomplete penetration, it's good for plate-to-plate connection where the full strength connection is not required. When full strength is not required, and it's again the same, it's the opposite side of the full penetration. It's poor performance in fatigue, and it's not the good welding for the structure facing to the earthquake load or static load, so no ductile capability, and always weaker than the plates being connected. The strength of the welding part is always less than the yield strength of the connecting plate. Always weaker than plates being connected. So it means that if you're going to connect this two plates, we just consider up to this point, and there's always a gap between two welding points, and there's always a big point, so it's not good for the static and the earthquake load, and always the strength of the welding part is less than the connecting plate. So the welding will fail before the plate. So you know that the failure always happen on the welding part, not the plate. So the weld will not reach to the yield point because you will get the welding failure before plate failure. Let me find incomplete. That's a meaningful. I think that's a right description for incomplete penetration. Just remember, no ductility capability, always weaker than the plate, poor performance in fatigue, and it will not develop the full strength. Okay, the second one is the fillet weld. Okay, the fillet weld, you know that using the fillet form, when you're going to connect two plates like this, there always penetration through the plates, and that's the welding part. Just remember, the weld can be weaker than the member connected. It's the cheapest weld to produce. In fact, it's the cheapest. It's not good for fatigue. And the welding process, in fact, can influence the design strength. That's the disadvantages. And 3, the weld can be weaker than member connected. Welds are weaker than members connected. That's a fillet, so if we're going to have the full strength, you should go for the full penetration, always. To have to use the full capacity of the plates and welds. So in this form, it's not good for fatigue loading, and always the weld are weaker than the member connected, but in fact it's the cheapest weld. So just remember, it depends on how you're going to. If you're going to use the full capacity of this plate, you need to have a full penetration. If now, just we can go for the fillet welding. In fact, this part we call compound. Welding. So in the case that is the combination of the more than one types of weld, we call it compound. For example, if we're going to connect this, there's a plate, for example, it's a T section. First run, you will fill this part. The second run, you will connect. In fact, there is a combination of two welding methods. We call the compound welding. Okay, that was the introduction to the welding, different types of the welding, and how the symbols. In the next video, I will go through the design of the welding, and I will explain how we can check the capacity of the welding or finding the length of welding based on the New Zealand standard.